Again, in that video, I will solve two other probability problems in the Excel files that Utkoca uploaded to Blackboard. First question. A professor gives only two types of exams, easy and hard. You will get a hard exam with probability 0.78. The probability that the first question on the exam will be marked as difficult is 0.94. If the exam is hard and otherwise, the probability is 0.18. Okay, what's the probability that the first question on your exam is marked as difficult? Describe events first as difficult, right? So hard, H, exam is hard, is hard. Exam is hard, H event. F first. Question is hard, marked as difficult, the same. Okay, write the question in math. The first question on your exam is marked as difficult. So, probability F is asked. Okay. Probability F is connected, is linked with two other events. Whether the exam is hard, if the exam is hard, first question might be marked as difficult, and if the exam is not hard, it's easy, first question also might be marked as difficult. And I need to mention again, H is exam hard, H complement is exam is easy, and H complement and H constitute partition, their intersection are empty set. That's important to apply law of total probability. By law of total probability, probability F equals probability F given H times probability H plus probability F given H times probability H plus probability F given H complement times probability H complement. So, shall we calculate that? F given H complement times H complement. If the exam is hard, the probability that the first question marked as difficult 0.94 if the exam is hard, and the probability of exam will be hard. The probability of that exam will be hard is 0.78 plus 0.78 plus what's the probability that F given H complement otherwise means the exam is easy, it's 0.18 to be marked of first question as difficult times probability H complement is 1 minus 0.78 because of constitute partition, two events, events that has constitute partitions, their unions are sample space, and we have only two events, exam is easy or exam is hard, so 1 minus 0.78. Okay, when we compute that, it comes 0.778028. That's the probability of first question is marked as difficult. First question on your exam is marked as difficult. Yes, that's asked. Exam is marked as difficult. What's the probability that your exam is hard, given that the first question on the exam is marked as difficult? Write the question in math again. Probability your exam is hard, given that the first question on the exam is marked as difficult. If the first question is hard, what's the probability that the exam is hard? That's the question. We will use bias because it's hard to decide what's it, but controversy of it, opposite of it, is much easier as we did there. Probability H given F equals probability F given H times probability H over probability F by bias. Okay. I already calculated probability F and I know here from there, so I am writing directly over 0. What's it? Closely, you can calculate these. Some of them are close values because it's hard to calculate for these exercise questions. The main point is solving this and showing how we solved it. Okay. Second question is already solved in the last videos, one of the last videos, but we have the same questions in two different Excel files, so I won't solve that. Not keeping video much longer. Okay. An oil explorer performs a test to determine whether oil is likely to be found in a certain area. The probability that the test indicates the presence of oil is 0.88 if oil is indeed present in the test area. And the probability of a false positive is 0.18 if no oil is present in the test area. Before the test is done, the explorer believes that the probability of presence of oil in test area is 0.38. Use bias rule to calculate the probability of oil being present in the test area, given that the test gives a positive signal. Describe the events. First, T test is positive. That means the petrol oil is present in the test area. No, that doesn't mean, sorry. The test is positive doesn't mean the petrol is present always, because the test might give the false positive. I will mention that. Sorry for that conclusion. probability I petrol oil is indeed the event I. Okay. What's asked? Probability of oil being present in the test area given that test gives a positive signal. Probability I given T is asked, right? Be present in the test area given that the test gives a positive signal. The test gives a positive signal. Okay. Probability. I will use bias firstly because it's hard to know this, but it's easier to know the things that I am writing now. Probability given I. Firstly, sorry. Probability I given T equals probability T given I times probability I over probability T. That's T by bias. It writes bias here. So, firstly, calculate the probability T. It might be long. Probability T equals T is connected to possible events, whether the petrol is indeed or either petrol is indeed or petrol is not indeed in the test area. So the test gives the positive signal with some different probabilities, depends on that event I. And I need to mention again, I and I complement, their intersection is empty set and they constitute partition in sample space. I mean, the oil can be indeed or cannot be indeed. That's not other possibility for that event. Probability T given I times probability I plus probability T given I complement times probability I complement Y. I will delete here. But it's better to be written in the exam paper by law of total probability. Evet. T given I. What's the probability of that? The test indicates the presence of oil. The probability that test indicates the presence of oil is 0.88. 0.88. If the oil is indeed I given times what's the probability I? It's 0.38 presence of oil in the test area. Okay? Plus false positive. If the oil is not indeed and despite that the test gives positive results, it's false positive. So the probability of false positive is 0.18 if no oil is present and 0.18 times I and I complement constant partition, their union is sample space. So probability, if the probability I is 0.38, probability I complement is 1 minus 0.38. When we calculate here, equals, when we calculate here, we get, I have to again, times plus 0.3344 plus 1 minus 0.1 minus 0.38 times I might be confused about calculations, but I don't think so. You can calculate it again. I already solved that questions. I'm solving again. Firstly, what is it? 0.1116 plus 0.3344, 0.446. That's the probability of t, but it's asked probability I given t. I'm writing them here. Probability t given I times probability I already did there. 0.88 times 0.38 over probability t. I've just calculated it. 0.446, and that's equal to, finally we get the results, 0. Closely, not certain. It's a long number, I've written it closely. That's all for that video. Thanks for listening and thanks for watching.